So the next problem is about matching the stuff. Write a question first. Design a single stub matching for the following transmission line. So a transmission line itself is given, which is like this. So ZL value is given. This is normalized value. So 0.4 minus J 0.4. So it's a given value. Actually, the line is simply given like this. There is no other value is given. So it means it's a normalized value, and Z0 and ZL are not same. If at all Z0 and ZL are same, it should have been right simply 1, correct? ZL equal to 1 means it is normalized. It's normalized and it is matched. But as of now, it is not matched. So the question is, right, to design to design a single stub. Let me assume that this is where I'm going to put the stub. Okay, so this is our stub. Okay, so let me assume that this is what I am supposed to design. You can assume a short-circuited stub, right? Two things to find, right? The similar diagram I had drawn when we discussed about the stub matching. The first thing is that where I am supposed to put the stub, right? That is what I'm going to call as, say, this distance from the load, where I'm going to put the stub. That is what I'm going to call as L1. I'm supposed to find the location of the stub. Okay, and let's go for another one. So that is like this, and this is the length of the stub. Okay, so that is L2, right? I'm supposed to find L1, that is the location of the stub. Okay, then L2, that is the length of the short circuited stub. These are the two things I'm supposed to find. That's what they have asked as the design the single stub. Are you okay? So recall the derivation we did, right? We are going to follow the same procedure now. Okay, so okay, anyway, let me bring up the Smith chart first, and then we'll proceed. Okay, so first point, always you mark the given impedance. All right, so this is the standard procedure for any problem wherein we follow we have to do the impedance matching problem. We have to solve that. Okay, whenever that is the case, directly mark the given point on the Smith chart. Okay, So what is the given value? If you look at that, it's given the Z value is 0.4 minus J 0.4. So 0.4 minus J 0.4 is somewhere here, right? So this is the point, correct? This is nothing but the ZL given. Is it okay? All right. So the first requirement is that keeping that as a center, keep measuring this distance, whatever is this distance, take it as a radius and draw a circle. Okay. So that is our first requirement. Draw a circle. I'll try to draw a circle over here. Let's see. Okay, approximately this is how the circle looks like for me. Okay, now once you have drawn this, right, once this is done, the next thing is that you need to draw. See, if you remember the derivation we did in order to perform the impedance matching, we converted the ZL into YL first, correct? Z into Y, impedance converted into Y values, correct? Admittance values. How to do that? It is 1 divided, correct? 1 by Z. So that 1 by Z operation, if you want to do, right, that 1 by Z operation is, it can be simply done by drawing a straight line through this, passing this, and extend that all the way till the outside. Okay, just do like this. So when you do that, you reach another point on the other side, right? Another point over here. This is the equivalent value, that is YL. Corresponding to ZL, when I take 1 divided by ZL, I get a YL. Okay, so do this, and whatever YL you get, you tell me what is that value. So I'll just make a note here so that we keep track of everything. So I'll write here the ZL value, which is given. I marked first, that is equal to 0.4 minus J 0.4. So drawing a circle of that radius equal to, from the origin to this ZL, we take it as the radius, and I complete a circle, and I extend the line connecting ZL and origin to the other side, all the way till the outside of the Smith chart. And wherever that line intersects the circle, I'm going to call that point as YL, and give me the value you get on your graph. And 1 point. Okay. So the value we get here is YL is equal to 1.1 plus J 1.2. Is it 1.25? Okay, fine. Right. Now, okay, this is the logic. The logic is that the same thing we had used in the derivation, right? Let me assume that there is a Z naught value, right? This is a real value. Okay, now when I look into this at this particular point, I am supposed to get 1 plus or minus whatever jx. This is what I am expecting. Okay, it is 1 because z0 and the real value, whichever we get here, right, they are matching. So divide by z0, z0 by z0 is 1. Okay, so the idea is that I should have a point where the Z0 and the real value of the impedance we get at the point where we insert the stub, it should match. Okay, that's the first point. And this Jx can be cancelled by making the impedance of this short circuited stub as minus Jx. You see that minus Jx plus Jx cancels, you have simply 1 over there. This is the logic, correct? You understand that, right? Okay, so in order to get this 1 at the first place, right, I can get 1 plus whatever, doesn't matter. Okay, 1 plus j5, I am fine with that. 1 plus j10, I am fine with that. I have to get a 1 first. Okay, so how do I get that 1? Let's go to the r is equal to 1 circle. Correct? Where is r equal to 1 circle? That is this circle. Whatever I'm marking now, I'm talking about that circle. If you want, you can make this circle as a darker circle on your graph. Okay, this circle is what I'm talking about. So you can make this circle darker by redrawing something over that. Okay, I'm just making a highlight of this. Okay, so this is the circle which is r equal to 1 circle. That means I have to reach, right, from this YL, right, I have to come towards the generator, correct? I have to move towards the generator so that I will reach a point where the YL has two parts, that is 1.1 plus something. This simply becomes 1. How do I do that? You move like this, okay? You move like this so that you reach a point where it is equal to 1. How do you find out that is equal to 1? It happens only at one point. You see, at this particular point. Can you see? At this point, right, my the blue colored circle intersects the r equal to 1 circle. Correct? So at that point, I have the y value has a real part that is equal to 1. Are you fine? So let me mark a point. So what I did, you recall, I actually moved this YL, right, towards the generator. That means clockwise, so that I intersect the R equal to 1 circle. So if you want to mark over here, simply just mark like this. I moved in this direction such a way that I reached this point. Okay. Which is the other point? This point, you're talking about this point. That is, you reach that point only if you move towards the load. It's already load. I cannot move towards the load further. Right? So there is no question of moving. Yes. Right? So the direction, you always remember that you want to move. So I'll quickly go back to my diagram. Right? From this load, I have to move towards the generator. That's all. Correct? So according to the convention we follow on the Smith chart, this has to be the clockwise. So that's why I'm moving only in this direction, right? You move and you reach this particular point where, right, what is the value of what's the value of new value of y that we are going to get it, right? We'll get I'm calling that as a, say, y1. Okay, this is what I call as say y1. That's y1 equal to, let me write, Okay, so you see what value it is. It's definitely 1 minus some. Okay, because it is on the one r equal to 1 circle, so this has to be 1. Since it is below, it has to be minus something. So you just refer your graph and tell me what is that value. Which we are getting on a practical Smith chart is 1.0 minus j 1.0. Okay, fine. Now you see, I have to cancel this part, the second part which I have here, right? I need to cancel that using this. But before that, now you see you have moved by such a distance on the transmission line towards the generator so that you reach the required point, correct? So that point is y1. I'll just show here. So this is what is my y1. When I look into this, I'm getting y1, which I measured now. So that is 1 minus j1. So this has to be the reverse of that. Here I should get the minus j1. Sorry, there is a minus j1. I should get a plus j1 so that this gets cancelled. Are you okay? So here I have 1 minus j1, right? I have to cancel this now. But now I am able to calculate a L1 directly. Simply calculate that on the Smith chart. How much we moved, that is the length. So how much we moved, how do you measure that? Already this point I know, right? I just have to measure this. What I do, I'll take another straight line. I'll draw a straight line connecting the origin with or connecting the origin and this line and extend this further outside. Okay, like this you draw. Now we need to measure two things. Okay, first thing is, what is this length? What is this value you need to measure? Until here we have moved so that we reach this. So I want you to read the value which is over here. Okay, I am moving towards the generator. So right from YL I am supposed to move towards the generator. So towards the generator means it's the outer value. One, okay, so I'll just write that. So you're saying that we are, this value which we are measuring here is 0.184 lambda, correct? Okay, similarly measure this value, what you are getting over here. So this is lambda, okay, in terms of lambda, right? So this is 0.338 lambda. So first I am calculating the length of position of the stub. Okay, is equal to the final value 0.338 minus what was the other value, 0.184, I guess, correct? Yes. How much? 0.502. No, you're subtracting, not adding. I think you should get a smaller value. 154. Okay, that's so this is 0.154 154 lambda. So we understand that in terms of lambda, this distance which we are supposed to cover, L1 we got, okay, 0.154 lambda. Okay, now you see we are actually looking at a short circuited stub. I just have to find out the L2 value. What should be the length such that I am able to cancel this, as I have to design a stub whose impedance value equal to plus j. I have to place it here, that's all. Okay, at this particular location L1 measured from the load, I have to place this particular stub such that it is going to give you an impedance of minus jx. Corresponding to that, there will be a L2. Okay, so let's quickly design that part. Right now you see I am designing a short circuited stub. Okay, so when we say we are measuring a short circuited stub, the short circuited stub impedance will lie on the outermost circle because there is a R equal to 0, correct? Only on this circle you have outermost circle, right? That's the first point. Just remember, always you have to find out a point on this now. Okay, only on the outermost circle. You will never go into the inside the Smith chart for this particular case. Okay, this particular case I am referring to the stub, right? What is the impedance of the stub? Now I know that the y1 is a point which has x value equal to, I think, minus 1, right? Minus 1. So find out a point on the outermost circle where you can measure plus 1. So according to me, that is this point. Can you see? This is the position where you get plus 1. Correct? So plus 1 in the sense, according to my problem, I'll go back here. So this is what I'm going to call this. When you measure, you get a y2, right? That y2 should be equal to j1, correct? So I already marked y1 over there. You see here, y1 is 1 minus j1. I'll add a y2 to that. The y2, if I design accurately as j1, this y1 plus y2 will become 1. Correct? So that's what is my requirement. So I have to make sure that I mark a point y2 on my graph, which is equal to the, you look at whatever is the value you have in the y1, right? Imaginary part, take a negative of that. Okay, so over there I can see that it is minus j1. I have to mark a plus j1. So for that reason, now I come on the will come to the Smith chart and I mark plus j1. So this is my y2. Are you okay? Why I mark this one? I have to mark plus j1 because already what is there in y1, right? What we see on the y1, I'll quickly show it here. See the y1 is minus j1, correct? So that means y2 should be plus j1. Plus j1 means above, correct? So that's why we are marking over here. So in some problem, you may get a y1 as 1 plus j2, so that you will decide y2 as minus j2. You mark a point which is minus j2, that's all. Okay, I'll give another problem to you for you to solve, wherein you will see that this something like this will be the case. Okay, so as of now, y2 is equal to plus j1 and I mark that over there. Okay, now the present value, okay, the present value of y1 is minus j1. It should become plus j1, means how much I should move and in what direction I should move. I just go back to my the transmission line. So you see here, now whatever I'm adding here is a new transmission line, correct? The short circuited stub is a new transmission line. For this new transmission line, correct, I have a value starting which is equal to minus j1, which should become plus j1. In the sense, along this particular line, I should move towards the load or towards the generator. You have to answer that. Am I moving towards the load or towards the generator? the direction which I marked here, this direction, this direction. This is the short circuit what I see here, right? Is it a load or is it a generator? Are you sure? You see, consider only this part, okay? This is my transmission line, okay? Don't consider the original transmission line. That is not there now, okay? It's so the short circuit is a load, right? That means now I have to start. This is the generator now. For this stub, which we are adding now, this part will look like a generator for that. And the short circuit, what you see there is the load. Okay, so I have to move from wherever I have marked Y1. From there, I have to move towards the load. Towards the load in the sense, it is which direction? Anti-clockwise direction. All right. So let us move, right? Now you move towards the generator, sorry, the load. And so now I am here, right? I have, okay, this is how you do that. So you can do the reverse also. You know that where is the J1? This point you already know, correct? I have to reach this point starting from this, right? So you just have to start from J1 and right, you can move towards this. Okay, so let's do that. So I have marked the distance like this. So the point which I have right now is, okay, now I will consider this one. Let me start from here. So I have, so the input of the stub is actually open circuited, correct? Input of this stub is open circuited. Open circuited means from where you will start. Open circuited point on my graph is this point, correct? This is the point, correct? So from here you start and move in such a way that you reach the Y2. Okay, so I'll draw a line for Y2 as well so that this becomes easy for you. So this is what is my point. Okay, now from here you start all the way. I need to measure the distance that is between these 2 points, this point and measure this difference. Okay, the total value that you are going to get when you move like this. Okay, this is the required length of the stub. Okay, start from the top. Between these 2 points, whatever you measure is this. So from here to here it is 0.25, right? Lower half is complete, that is 0.25. Then measure this distance and add to that. Okay, so what is that distance? You just have to tell. That will be the L2. Also we measured L1, right? L1 already we have written that value, I guess, right? How much was the L1? Yeah, I have written that. Okay, so now I need just L2. 2.124. How is that? Okay, that is 0.124. To that I am adding, okay, I'll just write 0.124 lambda plus the 0.25, right? Because the lower half complete is 0.25. 0.25. So that becomes 0.374 lambda. 374, right? 374 lambda. So you see now that means the length L2 of this stub, which we have measured now, is right equal to this value. Okay, L2 we calculated from the graph. Okay, so the procedure is going to remain same, right, irrespective of what is the given problem. Okay, whatever the problem we are facing, we can simply solve. Okay, so I'll give you a problem to solve. Okay, this is a homework question, right? Let's assume that we have the similar transmission line like this. Everything is normal, okay, normalized, and the small ZL load is equal to 0.3 plus J 0.5. Okay, so this is the one, right? You are supposed to match a stub like this. So supposed to find out what is L2 and what is L1 in this case by using the Smith chart. Okay, this is the problem you have to solve.